Imagine stepping off a modern ultra-fast bullet train.
Right.
Like the doors slide open, you walk down the platform, you step out onto the street in Tainan, Taiwan.
Right.
And suddenly you are looking straight at the bleeding edge of 1960s engineering. You can literally walk right up and touch a machine that fundamentally changed human history.
Yeah, it's wild.
But then you turn around, walk just a few hundred yards across the street, and you step directly into this blueprint for 21st century survival.
It really is like a physical timeline right there. I mean, in a 5-minute walk, you move from the foundational technology that allowed us to conquer distance straight into the sustainable technology that we desperately need to, conquer climate change.
And that is exactly what we are exploring today on this deep dive. I'm super excited about this one. We've got a really fascinating stack of sources to guide us through this single, incredibly dense geographic hub right around the Tainan High-Speed Rail station.
Oh, yeah. The sources are great.
Right. We're pulling from the historical archives of the Taiwan High-Speed Rail Museum, and we're analyzing some really cutting-edge architectural blueprints from design firms, path and landforms, and bioarchitecture for Masana. Plus, we're digging into the government planning documents for the Shalun Smart Green Energy Science City.
Yeah, so we're going to cover a bit of that foundational rail history first at the Oiran Scenic Park. But, well, we'll be spending the bulk of our time looking at what's happening right next door at the Shalun demonstration site, because the technology they are testing there is, quite frankly, it's just mind-bending.
It really is. But let's start with that massive piece of history sitting right outside the station. I mean, if you just arrived in Tainan, you literally cannot miss it.
Yeah.
It's the centerpiece of the newly opened Oiran Scenic Park.
And it is an absolute legend in the train world. We are looking at the Zero Series train, specifically car number 215035.
Okay.
And if you know anything about railway history, the Zero Series is like the holy grail. It was the world's very first high-speed train.
Oh.
Yeah, the original Japanese bullet train with that iconic, rounded airplane-like nose.
Right, so this is the one built for the 1964 Tokyo Olympics, right?
That's one, exactly. When it debuted, it was hitting 210 kilometers per hour, which was unheard of. I mean, it practically chopped the travel time between Tokyo and Osaka in half.
That's incredible.
But what's really incredible is that this specific line of trains ran for 44 years with an absolutely flawless safety record. 0 fatal accidents in 44 years.
Wait, okay, hold on. A 1960s Japanese bullet train built for the Japanese Railway, sitting in southern Taiwan. Like, did it just get lost? How did it end up as the centerpiece of a park in Tainan?
Well, it got a very unique second life. So in 2004, while Taiwan was building its own high-speed rail system, JR West actually gifted the specific Zero Series train to Taiwan.
Oh, okay.
But it wasn't brought over to carry passengers. It had a much more dangerous, gritty job.
Okay, here's where it gets really interesting, because this is the part of the archives I found absolutely fascinating. They didn't use it as like a VIP transporter or a museum piece right away. They completely stripped this beautiful, sleek passenger train down and turned it into what is called a limit measurement car.
Exactly. I mean, think about the infrastructure required for a high-speed rail line.
Right.
You are building hundreds of miles of concrete tunnels, elevated bridges, tight station platforms before you can safely launch a modern passenger train down those tracks at 300 kilometers per hour. Your margins of error have to be literally zero.
Zero.
Yeah, if a tunnel wall is poured even a fraction of an inch too close to the track at 300 kilometers an hour, that's a catastrophic disaster.
So how do you test that without, risking a brand new multi-million-dollar train? You take this retired 1964 bullet train and you basically cover it in physical probes. I mean, the photos in the archive are wild.
They really are.
They stuck these long sensor pins and ultrasonic detectors all over the roof and the sides of the train. It's like a mechanical porcupine.
That's exactly how it functioned. They would push this modified train down the newly constructed tracks. And if any of those extended pins physically scraped against a tunnel wall or a bridge support or a platform,
The engineers immediately knew they had a clearance issue.
Exactly. They knew exactly where the problem was and that it needed to be fixed. It physically mapped out the safe space for the new trains to occupy.
A mechanical porcupine doing the dirty work.
But wait, Porcupine is entirely unromantic. And I noticed the park isn't called Porcupine Train Park, it's the Oiran train. So where does that name come from?
Yeah, so that comes from the Japanese engineers who modified it. And it's just this brilliant example of how rigid engineering can inspire, like, poetic cultural observation.
Oh, I love that.
Yeah, so Oiran refers to the high-ranking courtesans of Japan's Edo era.
Okay.
And these women were famous for wearing these incredibly elaborate, complex hairstyles, and they were filled with dozens of long, multi-pronged hairpins that extended outward in every direction.
Oh, wow. So they looked at this train with all these metal measuring pins sticking out of its head, and it reminded them of the spectacular hairpins of an Oiran. The nickname just caught on immediately.
That is so cool. It takes this purely utilitarian mathematical machine and just gives it a soul.
Right.
And if you go to the park today, you aren't just looking at a rusty piece of construction equipment. I mean, they went through a painstaking restoration in 2019.
They really did. They went all out.
Yeah, they sourced the original 1960s paint codes, the classic blue 20 and cream 10. They restored the aerodynamic skirt. And it sits under this stunning radial wooden canopy that mimics a traditional fan-shaped train garage. It's just a gorgeous tribute.
It is beautiful, but as beautiful as it is, the Oiran train represents the peak of 20th century problem solving. It conquered distance. It made it possible to travel from Taipei to Tainan in just over an hour.
Right, but that created a completely new problem, didn't it?
Exactly.
Suddenly, because of this train, you have thousands of people arriving in Tainan every day. And they're demanding modern infrastructure, laboratories, housing, and Tainan's climate is brutal. I mean, it's south of the Tropic of Cancer.
Oh, it is relentlessly hot.
Yeah, very dry, and the sun just bakes the earth.
So how do you build a massive city for these people without totally destroying the environment?
Well, that is the exact question answered by the area just a few minutes walk away, the Shalun Green Energy Technology Demonstration Site. Because traditionally, modern architecture fights a harsh climate. You drop a massive glass and concrete box onto the dirt, you seal the windows shut, and then you just pump it full of electricity to run industrial air conditioners 24/7.
Just to keep the humans inside from melting.
Right. It's a brute force battle against nature.
Okay, let's unpack this. Because the blueprints we have from the architects here, Bioarchitecture Formosana, they show a totally different philosophy. It feels to me like they didn't build a facility. They planted it.
Planted it. I like that.
Yeah, like a tree, using its leaves to catch the breeze and shade its own trunk so it naturally thrives in its microclimate. Basically doing the exact opposite of that concrete box idea. That is a highly accurate metaphor, actually. And the physics backing it up are fascinating. So, let's look at the trunk first.
Okay.
The entire 7.4-hectare complex is not aligned to a standard north-south-east-west city grid. If you look at the master plan, the central axis is tilted at a highly specific 230-degree angle.
Wait, why 230 degrees? That's so specific.
Because of the wind and the sun. The architects mapped the exact trajectory of the intense Tainan sun, and more importantly, they mapped the prevailing summer winds coming up from the south.
Oh, wow.
Yeah, so by angling the massive building volumes at exactly 230 degrees, they created natural aerodynamic wind corridors between the structures.
So the buildings are literally catching the prevailing wind.
Exactly. They catch it and funnel it through the complex, naturally dropping the ambient temperature of the pedestrian walkways and the building exteriors.
So they basically engineered a permanent natural breeze.
Yep.
That's wild. And what about the leaves in that tree metaphor?
Well, those would be the perforated aluminum panels attached to the building exteriors. They act exactly like a canopy of leaves. They provide shade and block direct solar radiation from heating up the concrete walls.
But they still let the air through.
Right, while still allowing that funneled wind to pass through the perforations.
But there's a catch to Tainan's climate, right? It's not just hot, it's really dry. And the sources mention this specific area in Shalun used to be farmland with this highly permeable, sandy soil.
It couldn't hold water at all.
Exactly.
Yeah.
But a terrible biodiversity. How do you build a massive, sprawling technology park and actually improve the environment in a place like that?
Well, you have to build a water source.
Yeah.
And the way they did it is an absolute marvel of engineering. They utilized the building's raft foundations.
Okay, let's pause there for a second. For those of us who aren't structural engineers, what is a raft foundation and how is it different from like a normal one?
So normally, to support a heavy building, you drive deep concrete pillars straight down into the earth. But a raft foundation is different. It's a massive, incredibly thick, continuous slab of reinforced concrete that sits under the entire footprint of the building. It spreads the massive weight of the structure over a huge area of soil, floating on the dirt exactly like a raft floats on water.
Oh, I see. And because it's so thick and massive, there's actually volume inside of it.
Precisely. The engineers essentially hollowed out vast, watertight compartments within these massive underground concrete rafts.
No way.
Yes. They turned the very foundation holding the buildings up into a subterranean cistern capable of holding 10,000 tons of harvested rainwater.
10,000 tons. That's a literal underground lake.
It is, and it isn't just sitting there. They pump that harvested rainwater up to feed a year-round ecological pool on the west side of the complex.
Okay.
And the impact of this is twofold. First, think about those 230-degree wind corridors we talked about.
Right, the funneled breeze.
Exactly. As the wind is funneled into the campus, it is forced to pass over this large body of water. The water absorbs the heat from the air, cooling the breeze significantly before it ever hits the buildings. It's a massive, zero-electricity, passive cooling system.
Oh, it's the oasis effect.
Exactly, the oasis effect.
Yeah.
And second, by creating a permanent, stable water source in a historically dry, sandy region, nature immediately returned.
Oh, wow.
Yeah, that ecological pool has attracted birds, amphibians, and fish back to the area. They've restored vibrant biodiversity to a place that used to be a dry, sandy field, and they used it to air condition a state-of-the-art research facility.
That is just brilliant. But you know, when I was looking through the photos of this site, something else really struck me. When you hear green energy technology demonstration site, picture a power plant, right?
Right.
You picture a sterile, restricted clinical laboratory surrounded by chain-link fences. But Shalun looks like a public art museum.
It really does. The visual experience is a heavily integrated part of the architecture. Like right at the entrance, you are greeted by the wind messenger.
Yes, the deer.
Yeah. They are these whimsical, stunning art pieces by the artist Su Sung-chi, featuring 2 deer and a pine cone, and they sit right next to a massive solar tree landmark that generates actual power while functioning as a shaded public gathering space.
Even the basic signage is artistic. The design firm, Path and Landforms, handled the wayfinding. And the 5 main buildings, they don't have standard issue, boring industrial signs.
No, not at all.
They feature these giant pixelated building numbers. And those pixels are derived directly from the grid systems you see on photovoltaic solar panels. They literally took the visual language of renewable energy and turned it into a font.
It's so clever. And remember those perforated aluminum panels we talked about, the leaves shading the buildings?
Yeah.
They cut incredible cloud-shaped totems into those panels. So they provide shade, but they also hide the building numbers in plain sight within the layers of metal.
That's awesome.
And even inside the energy center, the complex web of pipes isn't hidden behind drywall. It's exposed and heavily color-coded based on exactly what kind of energy or fluid is flowing through them.
Which brings up a really important question. I look at all this art and design, and I have to play devil's advocate for a minute.
Go for it.
We are talking about a national testing facility for grid technology. Is all this art just window dressing? Like, does making a power plant look like a modern art museum actually serve the scientific mission of the park?
What's fascinating here is that it absolutely serves the mission. In fact, it might be the most crucial part of the site, because the ultimate goal of Shalun isn't just to invent new technology in a vacuum. The goal is commercialization. It's public adoption.
Oh, right. You want people to actually buy this stuff and put it in their cities.
Exactly. And historically, energy generation has a very harsh, intimidating industrial vibe.
Yeah, it's loud, it's dangerous, it's hidden away behind barbed wire.
Right. So if you want the general public and private businesses to embrace green technology, you cannot intimidate them with it.
That makes total sense.
By softening that harsh industrial vibe with the wind messengers and hiding the numbers in cloud totems and literally color-coding the pipe so anyone can walk in and visually trace how energy flows, they are demystifying the machine.
So if it feels approachable, natural, and beautiful, people won't be afraid to integrate it into their daily lives.
Exactly. You can't get the public to adopt sustainable tech if they're intimidated by it.
Okay, so let's talk about that integration.
Yeah.
What is actually happening inside these brilliantly designed wind-cooled buildings?
Well, this is basically the plug-and-play testing ground for the entire country. We call it the last mile of green tech.
The last mile.
Yeah, like a university researcher might develop a highly efficient new material in a lab. But before a construction company can legally or safely sell it to the public, it needs to be brutally tested in the real world.
And looking at the blueprints, the most extreme tool they have for this testing is called Scenic Lab, the subtropical green building tech testing platform. I have to say, when I first read the documents for this, I thought my eyes were playing tricks on me.
You're not the only one.
Yeah.
No, you read the schematics correctly. SPIAN Lab is literally a rotating testing platform. It's a rotating building.
I need you to explain the mechanics of this, because my brain just short circuits trying to picture it.
Yeah.
How do you take a physical building with walls, plumbing, and electricity and just spin it around?
It requires some incredible mechanical engineering. So the entire structure of SPIAN Lab sits on a heavy-duty circular rail track, similar to what you might see moving heavy cranes at a shipping port.
Okay.
And the building is mounted on motorized bogies, basically heavy-duty wheeled chassis that roll along this track.
But wait, what about the wires and the pipes? If you spin a house, wouldn't you just rip the plumbing right out of the ground?
That is the genius part. The core of the building features a central pivot point with flexible rotating utility joints.
Oh, wow.
Yeah, all the electrical data and water lines come up through the center axis on swivels, so the entire building can rotate 360 degrees without tangling or snapping a single wire.
Okay, the engineering is amazing, but wait. So if I invent a new type of energy-saving window, I can just plug it in this building, and they will physically spin the entire structure around to test how it handles the morning sun versus the afternoon sun.
Exactly. That's exactly how it works. You bring your prototype window to Shalun, and because SPIAN Lab is modular, they literally physically pop out a wall panel and plug your window right into the side of the building.
That is so cool.
And then, yeah, they use those motorized tracks to physically spin the building to face east. They test how it handles the intense low-angle morning sun. Then they rotate it to face west to test it against the glaring baking heat of the afternoon.
It's like a physical modular wind and sun tunnel for architecture.
It really is. They can swap out walls, HVAC systems, smart lighting, and expose them to every possible solar angle and wind condition. They generate the hard data needed to rewrite Taiwan's national energy-saving building codes.
But the sources show it isn't just about a single rotating building, right? They're testing an entire integrated ecosystem.
Right. If we zoom out, the campus is simulating the future of daily life on a macro scale. Inside the site, there is an energy control center that simulates regional power grids.
Why do they need to simulate the grid?
Well, one of the biggest flaws with renewable energy is intermittency. You know, the sun goes behind a cloud or the wind stops blowing and your power drops.
Right.
So how do you inject that violently fluctuating power into a stable city grid without causing brownouts? They are actively solving that bottleneck right there in the control center.
And they aren't just simulating it with computers. People are literally living inside the experiment. Because right next to the demonstration site is the Circular Economy Housing Project.
Yeah, and this is a massive step forward. So a linear economy is what we do now, right? Take resources, make a product, and throw it away. But a circular economy is a closed loop.
So how does a housing project close the loop?
Through aggressive resource sharing and recycling. The buildings are constructed from recycled materials. They use a smart grid where solar energy is shared between units depending on who needs it.
Oh, that's smart.
And the water system is a closed loop where gray water from a shower is captured, filtered, and then used to irrigate the community gardens. It produces virtually zero waste.
And it is so cutting edge, so highly regarded, that TSMC, the largest semiconductor manufacturer in the world, stepped in and rented all 351 units for its staff.
Yes, they did.
They are living in a working prototype of a sustainable neighborhood. And just down the street from them, there is an autonomous vehicle testing track.
Right, but this isn't just like a flat piece of dry asphalt for a self-driving car to cruise on. This track is designed to throw everything at the AI.
Oh yeah, the weather simulations.
Yeah, exactly. It simulates complex 30-kilometer-per-hour urban traffic. It deploys dense artificial fog, and it uses sprinkler systems to simulate heavy rain. They test how autonomous cars detect and avoid pedestrians and bicycles in the absolute worst conditions.
Even retail spaces are in on the ecosystem. Because the local Mitsui Outlet Park shopping mall nearby is designed with massive solar arrays built into its roof.
Yeah.
The mall is basically acting as a decentralized power plant, generating 4 million kilowatt hours of solar energy a year to feed back into the grid.
It is just an incredible concentration of innovation.
So what does this all mean for you, the listener? It's easy to read about concepts like zero carbon, smart grids, and circular economies and feel like they're just, academic buzzwords, like they're far off theory.
Right, like science fiction.
Exactly.
Yeah.
But looking at what is happening in Tainan shows us that these aren't just papers collecting dust. They are physically being tested, spun around, and lived in right now. They are actively rewriting the building codes that will dictate the temperature, the cost, and the design of the homes we will all be living in a decade from now.
It is the laboratory where the survival of the 21st century is being hammered out in real time.
Which brings us really full circle on our journey today. We started by marveling at the poetic Oiran train, this heavy analog machine that used physical metal pins to scrape against tunnel walls, mapping out the space for humans to move at unprecedented speeds.
Yeah.
And then we walked across the street to a 230-degree angled, wind-cooled, digital green tech hub that is actively mapping out the space for humans to sustainably exist on this planet.
And looking at that arc, from 1964 to today, it leaves us with a really fascinating implication to consider.
Was it?
Well, the Oiran train is now a museum piece. It's preserved because it radically changed how human beings move through the world. So, looking at the Shalun demonstration site today, we have to ask 50 years from now, which piece of technology sitting in that park will we be putting in a museum because it radically changed how human beings survive on this planet? Will it be Spine Lab? What happens when we inevitably connect that kind of mechanical architecture to advanced AI?
Oh, man.
Right. Imagine living in an entire city block of buildings that behave like living organisms, physically shifting, tilting, and rotating on their own throughout the day to perfectly chase the sun and the wind.
Rendering static, unmoving architecture a relic of the past.
Exactly.
Now, that is an incredible image to mull over. A city that literally shifts around you as the sun moves. Well, thank you for joining us on this deep dive into Tainan's past and its brilliant future. Keep learning, keep questioning, and above all, stay insanely curious.